Welcome back to Data Explained channel, where we make complex topics easy to understand. Today we talk about data representation assumptions. Every data representation is built on assumptions. These assumptions are rarely written down, often taken for granted, and frequently forgotten over time. Yet they shape how data is interpreted, processed, and trusted. Representation assumptions are the implicit beliefs encoded into how data is structured, measured, and stored. Some assumptions are obvious. Others are deeply hidden. Consider a simple numeric value. A number stored in a dataset is assumed to be measured in a specific unit, within a certain range, and under specific conditions. If any of those assumptions change or are misunderstood, the number loses its meaning. Time data provides a clear example. A timestamp assumes a time zone, a calendar system, an epoch, and a level of precision. If any of these assumptions are not shared between systems, the same timestamp can represent different moments in time. Categorical data also carries assumptions. Labels assume stable definitions. Codes assume consistent mappings. Ordered categories assume meaningful order. When categories evolve, split, or merge, earlier assumptions may no longer hold. Even missing data reflects assumptions. A missing value may mean unknown, not applicable, not measured, or deliberately withheld. Treating all missing values as equivalent is an assumption, and often an incorrect one. Representation assumptions also appear in scale. Numeric values may assume linearity, continuity, or proportionality. Encoding choices may imply relationships that do not exist. A numeric representation can suggest mathematical operations that are not semantically valid. Assumptions extend beyond individual fields to entire datasets. A dataset may assume that samples are independent, that measurements are comparable, or that definitions are consistent across time and sources. These assumptions may be valid at creation, but invalid later. The most dangerous aspect of representation assumptions is that they often remain invisible. Data appears correct. Systems operate normally. Results look plausible. But conclusions are quietly shaped by assumptions that no longer apply. This is why data reuse is risky. Data is often used far beyond its original context. New users inherit representations without inheriting the assumptions that justified them. Professional data systems treat assumptions as first-class concerns. They document them, they encode them explicitly when possible, they test their validity over time, and they revisit them when systems or contexts change. Good representation design does not aim to eliminate assumptions. That is impossible. Instead, it aims to surface assumptions, constrain them, and make their impact understandable. Because data does not speak for itself. It speaks through the assumptions embedded in its representation, and understanding those assumptions is essential to understanding the data.